This is for week 15, lesson 2. Okay, so in the last lesson, you were learning about reference angles, right? And the reference angles that you were learning about were on the unit circle. Okay, now this lesson is still on reference angles, right? They're still acute, they're still made with the x-axis, they're still positive. Okay, but these angles that I'm going to give you in radians are not going to be on the unit circle. Okay, so what I want you to think about before we do anything else is the fact that this spot over here on the far left is considered to be pi. Now, there's an infinite number of ways that you can write pi, right? I'll write some over here. You could write it as 2 pi over 2. That's still pi. You could write it as 3 pi over 3. You could write it as 100 pi over 100, right? All of those still equal pi. All right, so if I ask you to find the reference angle for, let's say, 7 pi over 10. So then the question is, well, where the heck is 7 pi over 10? So what I want you to do first, when you see that denominator, is I want you to change the pi that's at the far left to be something with the same denominator. So in this case, I'm going to change that pi to be 10 pi over 10, right? Because that's still pi. So if this spot over here is 10 pi over 10, this spot right here has to be half of that, or 5 pi over 10, right? And think about that. That reduces to pi over 2, which is what you're used to on the unit circle. Okay, so if that's 5 pi over 10 at the top, and 10 pi over 10 is over here on the left, doesn't it kind of make sense that the 7 pi over 10 would have to be somewhere in the middle? Okay, and now this is not exact, okay? I know it's not exact. I just want some sort of a picture of 7 pi over 10. Because now I know that this is the reference angle. That's what I need to find out. And I know that from this spot to here is 7 pi over 10. And from here to here, all the way, in fact, let me change that right here. No, not that color. Maybe that. There we go. All that way is 10 pi over 10. So that little shaded part here has to be 3 pi over 10. So the reference angle for 7 pi over 10 is 3 pi over 10. Okay, so that's kind of an arrow. Okay, so if I give you 7 pi over 10 and I ask you for the reference angle, you will tell me that that is 3 pi over 10. Okay, so let me get rid of some of this stuff and see if I can try another problem. Okay, so just a reminder, this was 5 pi over 10. Okay, so think about this. If from here to here is 5 pi over 10, and then from here to here is 10 pi over 10, then if I go one more, this down here at the bottom should be 15 pi over 10. Ooh, and if I continued, if I went all the way around, that far right-hand side, that should be 20 pi over 10, which hopefully makes sense. That's 2 pi. All right, so let's try a whole new problem. Let me see if I can get rid of this. Okay, so let's try another one. How about 11 pi over 10? Okay, so the question is, where is 11 pi over 10? All right, well, it's bigger than 10 pi over 10, and it's less than 15 pi over 10, so it's got to be in this quadrant somewhere. 11 pi over 10. So the question is, how many radians are there here, right? Because reference angles have to be positive, they have to be acute, and they have to be made with the x-axis. All right, so hopefully this one's not too hard to see. If I go from here to here, this is 10 pi over 10. If I keep going, that's 11 pi over 10, which makes this reference angle 1 pi over 10. Okay, let's draw another one. And again, I highly suggest on these problems that you draw pictures. The more pictures you draw, the easier these problems are. All right, so let me get rid of this problem. And let's draw another one. How about 17 pi over 10? 17 pi over 10, which is more than 15 pi over 10 and less than 20 pi over 10, so it's somewhere over here. 17 pi over 10. And when I draw the picture of my reference angle, it's here. Okay, so again, it's like I'm just a little bit short of a full rotation, right? This, if I went all the way around, would be a full rotation, but I'm short. How much am I short? I am short 3 pi over 10. Okay. Now, let's try a negative one, because you will be given some negative angles on this worksheet that you're going to be doing. So let me get rid of some of this stuff, and we'll try a negative one. How about negative 19 pi over 10? Negative 19 pi over 10. Now, if I did this in the positive direction, right? If I started here and went in the positive direction, I'd go all the way around and almost make it all the way around, right? I'm so unbelievably close to 20 pi over 10. I just have to do this in the negative direction. So if I go negative the same amount, I end up over here. This is what negative 19 pi over 10 looks like. And this teeny tiny little angle is the reference angle. All right, so the question, I guess, is how far away are you from a full rotation, right? How much more would you have to go to get all the way around? And you would have to go pi over 10. Again, don't forget, reference angles are positive. It doesn't matter if the given angle is negative. Your answer, no matter what, will be positive. Okay, let's try a different denominator. Brand new sheet here. Let's see how this works. Okay, so for this one, I'm going to do some things that have a denominator of 8. Okay, so let's try. So actually, hold on. That means that over, in fact, hold on, backing up. Sorry. Let's try 11 pi over 8. All right, so the fact that this denominator is 8 means that this pi over here, I'm not going to write it as pi. I'm going to write it as 8 pi over 8. Right? That still equals pi, but it kind of lets me know that since I'm dealing with 11 pi over 8, that I'm more than that. I'm more than halfway around the circle. Now, am I all the way around the circle? Well, this is 16 pi over 8. So I'm not all the way around, but I still am not quite sure if I should be here or here. So what's down here in the middle, right between 8 and 16? Well, that would be 12. 12 pi over 8. So that means that this angle that I'm trying to deal with is in quadrant 3. It's not this guy, right? It's somewhere in here. 11, oh wait, you can't see that. 11 pi over 8. And this is the reference angle, right? So if to here is 11 pi over 8 and all the way to the blue line is 11 pi over 8, then the reference angle, that little bit more that I went, is 3 pi over 8. All right, let's try another one. Let me erase this one. Give me a sec. I may have to rewrite some stuff, but there's things in my way. All right, so let's try 13 pi over 8. All right, so from before, I know that this is 8 pi over 8. This is 16 pi over 8. And this is 12 pi over 8. So 13 pi over 8 is right here. That's 13 pi over 8. So keep in mind, the reference angle is acute and made with the x-axis. I realize that this little one over here, right, I'm putting some dots in there. I know that that is more acute, but it's not made with the x-axis, so you don't get to use it. So the question is then, if I'm trying to get from 13 pi to 16 pi, how many pi's is that? Well, it's 3 more pi. Over 8. Don't forget the denominator. Okay, let's try a brand new here. Next page. Let's deal with this one in terms of denominators of 5. Okay, let's do 5. So let's say I wanted 3 pi over 5. Okay, which means this pi is not going to just be plain old pi anymore. It's going to be 5 pi over 5. And over here, this will be 10 pi over 5. Whew. Okay, so then what's this top one? Right? What's half of 5 pi over 5? Well, it's like 2.5, right? Half of 5 is 2.5. I'm not going to write that, okay? Because 2.5 over 5 is a complex fraction. It's gross, it's ugly looking. It's not mathematically correct. But I know that 3 pi over 5 is more than it. It's over here somewhere, 3 pi over 5. So when I try to figure out this reference angle, right, you just have to kind of ask yourself, how much more do I have to go from 3 pi over 5 to get all the way here to 5 pi over 5? And that reference angle would be 2 pi over 5. All right, so if you've got other questions, please make sure you hit me up in Zoom.